Hey guys, it's Mrs. Conway. So what I want to do next is I want to make a video that goes over the notation we use for congruent segments and congruent angles, as well as perpendicular and parallel, because those come up in basically the rest of all of what we're going to do for geometry. So I'm going to hit pause here and flip my camera over, and I'm going to take my face off so that I can write on the notepad here. So you need to have a notebook out so you can take some notes. This also goes with question 17 on student activity sheet 2 if you're trying to follow along and fill that out. I would say sorry, not 17, 19. It takes up way more space than you're going to have. So you might just want to get out a math notebook and then sum it up in there. So all right, hopefully I have this so that you are not looking at the ceiling too much, but if you are, I'm sorry. I couldn't figure out how to turn off the thumbnail camera. So that's my microphone so that it's a slightly better audio quality. So the notation we need to be able to talk about, first of all, is congruent angles. So if you went through the Agile Mind slides, you saw them talk, or sorry, not congruent angles. We're going to do congruent segments first. So you might want to write congruent, a title on your notes here, congruent segments. And so if you were looking at Agile Mind, they gave you the example of segment JK and segment RS. And they put a tick mark on each of them to indicate that they were congruent to each other. And it talks about the fact that if you have the measure of angle JK equal to the measure of angle RS, like if you're measuring them with a ruler, they should be exactly the same. I can't guarantee my drawings are actually the same. But then you can put that they're equal. But if we're talking about the fact that if I were to take RS and actually lasso it with my little lasso thingy, and move it over here, and then rotate it, which I'm having a little trouble doing here, then I could actually make it match up with JK. It's not perfect, but it's close. So that means that RS and JK are actually what we call congruent. So when two segments are congruent, that means they're essentially the same segment, copied and pasted and maybe rotated. So when we say JK equals RS, we're saying the measures of the two segments are the same. So that's saying two numbers are equal. When we're saying JK segment is congruent to segment RS, we're saying that the line segments are the same segment copied and pasted and moved. So we're comparing a line to a line, so it has to be an equal sign with a squiggly on it instead of a straight up equal sign. Now, what could also happen is maybe I have two more segments. Maybe I have PQ, which is distinctly shorter, and RS. Oops, I already used RS, sorry. PQ and SN, which are distinctly shorter than JK and RS, but also the same as each other. Now I'm going to use two congruent markers. So this means that PQ has equal length to TU, and segment PQ is congruent to T. So it is important to distinguish between when two segments are equal in length and when they are congruent to each other. They are going to tell us the same information, but we have to be careful how we use them. One can be used to set up an equation, the other can't. So the next thing we talk about is congruent angles. So congruent angles is the same thing. If you have angle A and angle F, and we know that if we measured them both with a protractor, maybe they're both 50 degrees, that they have the same measure, then we would say that the measure of angle ABC equals the measure of angle. And now with angles, if we want to use an equal sign between them, we have to put this M in front of the angle sign because M means measure. if we want to talk about them being congruent, we take off the M and we just would say angle ABC is congruent to angle DEF. If two angles have the same measure, they are congruent. But again, it's two separate statements. When we're saying that they're congruent, we're talking about the fact that if I copied this angle, rotated it, and moved it over, they would line up, hopefully, if I drew it right. But let's say we have two sets of congruent angles, but this other set is obtuse, so they're clearly not congruent to the first set. I don't know why I'm doing this. We could just label them with one letter. This is angle K and angle K. These angles are each 100 degrees. So these angles are not congruent to the first two, but they are congruent to each other, and we have a notation for that as well. You can either mark them with two hashes, or you can make one hash with two tick marks in it. And same thing over here, you could put one tick mark in each of these to indicate that they're congruent to each other and that you're not just drawing the angle or something. So, two different ways to mark congruencies, they basically mean the same thing. All right. The next thing that you might see is perpendicular. Perpendicular means 90-degree angle, and another word for that is a right angle. Hopefully you knew that. So if I have a perpendicular angle, the way I'm going to notate that is I'm going to put a box in the corner. And I also might talk about how if this is and C, ray BC is perpendicular to ray, so that's how I would notate that. So that's perpendicular. And then the last one you might see is parallel. Well, not the last one. The last one I'm going to talk about on this video. Parallel lines or segments or rays never cross, and you might also talk about the fact that they're always the same distance from each other. So if we're talking about, say we have line L and line K, assume I actually drew those parallel. I know that my lines aren't perfect. To indicate that they're parallel on the drawing, we would draw little arrows on the lines like that, in the middle of the line. And then to indicate it in math notation, I would write L is parallel to K. I could also have two segments. Maybe these two are not parallel to the original two, but they are parallel to each other. By the way, parallel segments don't have to be congruent. They just have to be going the same direction. And to indicate that these two are parallel, I might put double hash marks on it. But so they're parallel to each other, but not to the original pair. And I would notate over here the same way, just now they're segments instead of lines. And remember, when we're talking about a line that's labeled, we don't have to put the line symbol on top. So there we have a lot of the notation you're going to use for the rest of your Delta Math. The last one we might just want to mention that just occurred to me because it comes up, a segment bisector. We've talked about angle bisectors, that they cut angles in half, and we've talked about just bisectors in general. A segment bisector would be that you have a segment like AB, and at point D you have a ray or another segment that actually cuts AB into equal parts, so you would mark that with congruent markers. So AD and DB are congruent, which means that DL is a segment bisector. A perpendicular bisector would be the same thing, but now we know that that's 90 degrees where the bisector hits. So it cuts the angle, it would have to cut the segment in half, and it is doing it at a 90-degree angle. So if you're ready, you can go work, but if you would like, what I'll do next is go over one example from Delta Math of using this vocabulary. So this problem set, bisector, midpoint, vertex on a diagram, you might need to use some of this vocabulary. So right here we've got a figure. It looks like a trapezoid on its side or something. And oops, we've got these statements, and we need to determine which ones are true. So MN is a segment bisector is our first statement. So if we look here, MN cuts LI into two congruent pieces. So it is a segment bisector. The next statement is MN is a perpendicular bisector. In order to be perpendicular, we would need an indicator here saying that that's a 90-degree angle, and there is none. So we can't select that. Next, it says MN is an angle bisector. The only angle that NM cuts is a 180-degree angle, and it is not marked as being congruent, and they're not 90 degrees, so it's not a perpendicular, or it's not an angle bisector. M is the vertex of a pair of congruent angles. No. M is the midpoint of a segment on a diagram. Yes, midpoint means exactly what it sounds like, the middle. So since it's equal distances from I and L, M is the midpoint of the segment LI. So since we selected some, it's not going to be none of the above. So that's the kind of problem you're going to have. So another one would be here. See, we've got our congruency markers. We've got this angle right here, SRT, is congruent to RTQ. But it's not congruent to the one it's next to. Those ones are, the opposite ones are congruent to each other. And we have a 90-degree perpendicular marking here. So when we come down here, TR is an angle bisector. If that were true, these two angles would have to have the same markings. But there's one that's a 1 and one that's a 2. So those are not. T is the vertex of a pair of congruent angles on the diagram. No, because T is the vertex of these two angles that are not congruent to each other. R, same thing. These two angles are not congruent to each other, therefore R is not the vertex of a pair of congruent angles. R is the vertex of a right angle. Okay, this one requires a little bit of extrapolation. So we know that this is a four-sided figure. We know that this is a right angle. Don't think at this point we can assume, no, we have no indicator to know that that would be a right angle at this time. T is the midpoint of a segment, so it's none of the above. So that's how we would do that problem set based off of the vocabulary that I went over here. A lot of this is going to come down to looking over the vocabulary, thinking about what the figure is. You might want to consider drawing these on a piece of paper so you can look at them a little better. Keep in mind this part about the diagram not being to scale. Don't assume things that are not explicitly marked on the diagram. So, I suggest you get to work on this assignment, and good luck.